Alright, so this is where we left off from volatility. So now opening up the project in Wireshark. We're looking for these particular two processes kind of as the first thing, because we know that these were ones we were suspicious of. If you remember that this iExplorer service and the WScript service both had these odd connections, and this 192.168.10 address was our local host, right? 10.128. So this is the connection between to the first of those. This is the first of those connections. If you look at the port, it's that port 3133 from port 1153. So the weird thing, so this is the SYN. You can see the SYN connection. This is the start of that connection. So we have this connection right from the start in Wireshark. And if you look down the packets here, we have SYN, SYNAC, and then I'm sorry, you don't have a SYNAC. So you have a SYN, and then it gets retransmitted a couple times, and then eventually it gets a reset back from the other side. And basically, to put a long story short, when you look down through what you have on this, that's all you get. Is you get a bunch of our subject machine is trying to open this connection. It's sending a SYN packet, sends it a couple times, it gets a reset back from the other side, and this just repeats over and over and over and over again, and so it never gets an acknowledgement from the other side. So whatever it's trying to communicate with on the other side is not accepting connections. So now we're going to go back and take a look at the other one. Right, we looked at the one, now we're going to look at the other connection. And so this one is going to port 1000 on that other IP address. And here we see the same thing. It sends a synchronization request, and eventually it just gets a reset from the other side over and over and over again. So whatever's creating these connections, the thing that's on the other side is supposed to be receiving the connection is not accepting the connection. So while this does look like it's traffic from the malware, probably because the ports that otherwise just really don't make sense, whatever is supposed to be listening on the other side is not listening. And that can definitely happen with like older pieces of malware or something. Whatever the machine is that's supposed to be listening on the other side isn't listening. Okay, so what are some other things we can look at? One of the first things I often do in analysis is use the statistics function to look at conversations. And so these are all the different things you can do statistical analysis on inside of a capture. The conversations is kind of the first thing I often go to. You can look at the conversations. If you look at these tabs, you can look at the different layers, right? Ethernet, IPv4, IPv6, if there are any, or TCP. I'm most interested in TCP. So, and then you can click at the top of any of these columns to sort by that thing. So I'm going to look at all the conversations. Like I said, you can do IP or TCP layer, even UDP if you're interested in UDP. And we generally are, the main thing we're going to see in UDP, and that's what you're looking at here, is all these connections to 8888. These are all DNS queries, and there are quite a few of them. And then there's a bunch of, there were some others, some other UDP conversations we may want to take a look at there. But the port, this traffic to 5355, for instance, that might be interesting. But the DNS traffic is often particularly interesting. So one way to look at it is to go to UDP port. Anything that involves UDP port 53 is going to be DNS traffic. So I'm only interested in DNS lookups from the one particular host that we're focusing on. So this query will show us all the DNS requests from that host. And so DNS is pretty fundamental. It's how you look up hosts, how you find how you resolve a name into an address. Typically, there's other things DNS does, but the most common thing is resolving from a name to an address. And these particular ones here are all, I think ATDMT. So I mean, you'll look at some of these and you won't recognize what they are. These days, there's a lot of content distribution networks that get called up, CDNs. They're for short. Like, I don't know what this amber.net thing is either, but you'll find a lot of, you can see there is a C name on the right. You can see that was what I was showing there. It's a C name for Akamai. Akamai is kind of the biggest and oldest distribution network, content distribution network out there. And this is where, and you can see this one, it says FB CDN that the pointer is pointing to now, and that's Facebook. It's content distribution network. So these are where generic content, especially things like photos and that sort of thing, get distributed from, that are part of web pages. Any kind of static content, streaming content, usually gets distributed through content distribution networks these days. And so a lot of your lookups will be for those kind of things. So here we see a lookup for blackhat.com. I mean, that's just a website for the Black Hat organization that runs a conference every year. We can see this is what the DNS query and result it looks like. That's the IP address for the that came back for blackhat.com. Normally that would not stand out as a big deal, but it kind of makes me suspicious as part of the as part of a lab, just because it'll stand out. So I'm going to go ahead and make a note of that here. But realistically, it's just a website. It's not, trying to go through every DNS lookup you see and every website you see in order to jump at things as being suspicious. You're likely to spend all day doing that. But the other thing I make note of when I make notes from Wireshark is the packet numbers, so I can go back and find where I found this thing. So I'm just going to make a note of that here for now and keep moving on. Keep going through the DNS stuff here to look for anything else that sort of stands out. See here at the bottom, there's a couple that stand out. You see this asmarani.noip.biz, and then there's another one down below that says byporcell.noip.biz. It's the noip.biz that stands out. So noip is a dynamic DNS provider, and noip is their free service. So anyone can sign up to have a DNS record set up at a subdomain like this asmarani and byporcell, a subdomain of noip.biz. And so anybody can sign up for that for free and get a domain name from noip.biz to point to any IP address. This used to be a super common thing that was used for malware because it was cheap and dynamic and easy, and you could even set it up with an API to have your malware automatically create and register these domain names. And so if you look at these IP addresses, you'll notice, if you were paying attention to the IP addresses, which I wasn't originally this is my voiceover, so I'm kind of reliving this. When I first was typing this, I wasn't paying attention, but if you look above, as I'm typing the IP addresses, it's pretty clear. It's pretty obvious that these IPs are those two IPs of the suspicious connections. The thing I'm pointing out there is that the subdomains are both kind of randomish, and they're 8 characters long. So you see that they're uniform length, which means they may have been created by some kind of program that was automatically creating them. And of course, these are the same IP addresses that those suspicious connections were made to. So the fact that we already knew those were kind of suspicious connections, now we know that whatever the malware was doing, it was using these noip.biz domains to find the IP addresses it was supposed to connect to, which just provides another layer of assurance that this is not normal activity, because that noip.biz, it's not that they're never used legitimately. I actually use them for stuff personally, but they're not used by legit websites, normal commercial websites. They're used by hobbyists, and people do simple things like if you have, say, some kind of device you're serving from your house, like a security cameras or something like that, and you want to be able to, and you have a dynamic IP address from your uh, service provider like Verizon or whoever, you might use a service like noip.biz uh, to create a domain name for yourself, so you can more easily look up what your current IP address is, and you can run a program that'll update your noip.biz record to match your current IP address as it changes. So it's handy for that kind of thing, but normal commercial websites aren't going to be using something like noip.biz. It's used for stuff of that nature, which when you see it in a lab in a security class, it's usually bad news. All right, so let's see what else we can find here. Let's get rid of the DNS stuff. Make sure I got the right address here. Oh, the black hat stuff. So I'm going to look up the black hat stuff, not DNS traffic, but all traffic. So let me get rid of that, and let's just look at everything from that black hat IP, just because we knew that the black hat seemed like it could be a sort of an indicator. And again, in real life, that's not usually that useful, but in a lab, in a security class, when you see something like blackhat.com show up, it's worth looking at. But when you look closer at this, it looks like just normal web traffic to port 80. The nice thing about port 80 is we can, the scrolling on this website just kills me. Or in the lab, where the window, I cannot get this window to fit in a normal full size to scale to like the size of my monitor. It's always just a little bit smaller when I do it on my Mac. So the black hat stuff, yeah, it looks like just normal web traffic. All right, so looking at conversations a little further, let's see what else we can see. One method with conversations, see, this is all the traffic to that IP address, and you can see it's all, there's some on port 80 and some on port 443, which are the normal web ports. That doesn't mean there's nothing bad going on. Bad stuff happens over standard web server connections all the time. So the ports don't indicate anything other than the fact that it is probably just normal web traffic, but it could be malicious web traffic in the sense that it could be used to deliver an exploit or something like that. So another thing I'll sometimes do is sort by duration. The duration lets you see the length of time that connections take. And what I'm noticing here is that there's two different source IPs within the 192.168 network, right? The 10.128 is our machine of interest, but there's also this 1.23. And they're both connecting to this same host, 204.79.197.200 on port 80. And if you look at the duration, they're all almost exactly the same. The rel start over there is just the start of the connection relative to the beginning of the capture. These are all around the same time that they went to browse the Black Hat site. There's also all these connections, this one IP address from two different IPs, which is what makes it so interesting. So I'm kind of curious about what this is. And wanting to find out. So what you can do is from inside this conversations view, if you point to a specific line in it, what you can do is right click on it and apply that as a filter. I usually just do the first choice, which is selected A to B. In other words, it's the selected line, and it's all the connections between that IP on that port to the other IP on the other port. In other words, it's everything that's part of that socket or that session. What I'm going to do here, though, is I'm going to get rid of the source port so that we can see all the connections from this IP to that IP on port 8 with port 80 as the destination ports. This will show all those sessions, not just one session. And so it looks like it's HTTP traffic. It's port 80, so we'll be able to read it. It should be unencrypted. And what we can do if we highlight these packets is we can see below what was in them. And what kind of traffic this was. So looking at it, it just says get slash, meaning it's just getting the home page of whatever this is. Looking down at the HTTP portion, we can see that it has a host header, and the host header says it's bing.com. So this is just regular web traffic to Bing, which is, of course, a search engine run by Microsoft. Unlikely to be anything malicious. It's worth making a note, by the way, of these kind of things, and you'll notice that I'm not really making notes when I make notes of when you find something you thought was suspicious, but it turns out it's not. It's good to make a note of that as well. And the reason it's good to make a note of that is because when you come back and look at it again, you're liable to notice it again and not remember, and you're liable to look at it and say, now why didn't I make a note of what this was? And you'll go investigate it all over again and then say, oh yeah, that was just the Bing traffic. And so you'll have to kind of keep going back and doing the same research over and over again. So even when you find things that are benign, it's good to make a note of them so you can quickly jog your memory as to why you decided that was benign, so you're not constantly going and essentially reinvestigating the same things over and over and over again. Okay, so let's go back to the conversations view and look at some other conversations. These are those Bing conversations. Let's look at some other interesting conversations. Any minute now. That's why it's hard doing voiceover on these. I'm trying to remember what it was I was thinking or saying at the moment when I was doing that. All right, so here's some. This was just reminding myself where that Black Hat IP address was. So these are some more sort of sessions where they're the same over and over again. But you see that number of packets, 31. It's not that many. So same thing here. What I'm going to do, since there's several sessions to this IP address, I'm going to get rid of the source port so we can see all of them at once within Wireshark. And scroll to the top here. All right, so same thing here in the sense that it's going to just the root website or the home page or something, get slash, right? Slash is just like get the home page, basically the root. Most the web's native language essentially is Unix. So if you're used to Unix at all, you'll understand slash being root. This one, interestingly enough, doesn't. It says server public file. This is the response. So these are just, this is more seemingly pretty normal web traffic, images, page graphics. Seems like pretty normal web browsing stuff. Nothing particularly interesting here. Alright, so going back to sessions again, looking for some more interesting sessions. This one here is the longest duration, and it's all over these two. These both ports are, not sure what those ports are, right? They're not normal ports. There's only 94 packets though, so you look at the number of packets is very small, even though the duration is high. So that's a little bit odd, but that's not even the source IP isn't even the IP. It's the 1.23, 192.168, 1.23 involved in that, not the 10.128. So looking at sessions for the 10.128, that's why I sorted here again, which is really the host we're more interested in. We've seen these. We know what that is. That's Bing. There's a couple of encrypted websites there, and I mean, encrypted. The thing about the encrypted traffic is, it's hard to investigate those because you can't read the actual session. You can't see what was actually happening. Now here's something interesting, because here we've got all these going to port 1000. This is all those, I'm sorry, we know what that is. This is all those failures where it's trying to connect and it just gets resets back. We already know what those are. You can see there's just 4 packets in every case, which we kind of already knew. No, we don't want to go to that because we've already been to that. We already know what that is. Why am I trying to go back to that? Okay, so here's another web connection applied as a filter. Let's see if there's anything interesting in this one. Okay, so it says it's getting something.crl. CRL is a certificate revocation list, and it's how issuers of SSL certificates revoke them, right? Because once you sign a certificate, it's signed for as long as until it expires. So if there were some kind of malfeasance that happened afterwards and you want to be able to revoke that certificate, the only way to be able to do that is by issuing an exception list or a revocation list. This is a connection to this arbiter.php. We can see the host, it's static.ak.facebook, and the referrer is Bing. So this is someone clicked from Facebook to this page on from Bing to this page on Facebook. So we can follow, once you're in this view, you can follow it as a stream and see the whole thing all at once. But there's really nothing terribly interesting here either. It's just this Facebook page. It's nothing malicious. All right, so going back to the conversations again. Here's these are all from 1.23. Let's scroll down to the 10.128 conversations. Okay, so just looking here for more that might have something something interesting to look at. Okay, so here again we are. This was just fetching a graphic. It's interesting that it's a redirect for a graphic, which is usually not what you're going to get. I wonder why it's trying to download this graphic. The other thing is that this graphic has a parameter, di equals 15074. It's a little bit unusual. You're looking for a graphic and then sending all this other stuff. But it may be that it's part of some kind of advertising tracking scheme. A lot of times this is how ads or other things track where requests are coming from, is by putting parameters even for fetching something like an image. So here's some more web traffic, where we're sending across these ID parameters. This host here is Bing, so this is just more searching. If you look below, you'll see that the query is for Johnny Long. This is quite likely the query that might have taken them the black hat. Johnny Long is a sort of almost celebrity hacker, like a geek rock star in the security world. He's actually he's an acquaintance of mine, a friend of mine. He's more like a friend of a friend than a friend. But he Like I said, he's kind of a big celebrity in the computer security world, and he actually is the founder of a charity called Hackers for Charity. You'll see them as one of the big charities that raises funds at a lot of big hacker conferences and stuff. He's over there doing aid work in the technology area, but it's aid work in Uganda, helping to. So I'm going to finally see what this long session is, even though it's not with our subject machine, because I'm just curious as to what it is. There's not a whole lot to this traffic. It's not really sending much of anything. It's just slowly sending just a little bit of data, and the packets are pretty far apart in time. It's like every 30 seconds or so it sends another packet if you look at the times over on the left. So this is kind of odd, and it makes me wonder if it's some kind of malware keep alive, a beacon of some kind for a backdoor. I mean, just given that the ports aren't standard ports at all, the data, I don't know what it is, it may be encrypted somehow. But it's not even on our subject machine, so we don't have any disk data or memory data from this host. So we don't really have any good way of finding out what it is. If the data is encrypted, we don't have anything on the host side to get at it with. This is another session from that same other host. It's a really long one. It's all on port 80, but I'll try to follow this as a stream here. It takes a while to filter out the whole stream. So whatever it is, we're kind of in the middle of it. We don't have the beginning of this stream, we only have it from the middle. It is lengthy, and it's all just a bunch of, we don't know what it is, right? It's not ASCII, it's not clear text ASCII. I don't know what it is. So it's a little bit hard. You can't really tell what you're dealing with. I mean, this is mostly, the majority of the traffic is being returned from the web server to the browser. So it could be streaming something. I mean, any kind of binary data or video data, or a download of some kind of anything that would be encoded or encrypted, or just in sort of a binary format, like a picture or something, would just look like gibberish when you look at it in that view, because there's no text to it. Yeah, so really kind of the same thing here. You can view it as TCP or HTTP stream. Generally speaking, there's not going to be a big difference. The difference is only in the which packets you get. You get the handshake if you follow the TCP stream. Whereas here we go. So it is a download of some kind of. It's a download of some kind of software, because you can see that it's got, like, this would be the help section or something. So there is some plain text in the middle of this thing, whatever it is. Loadlin is a component, a Linux component. So this is almost like some kind of piece of binary software for a Linux machine. There we go. Here's some more releases of packages for different Linux. Gives it looks like hashes of different releases of this software for different Linux releases. Loading into RAM disk. CPU is. Yeah, so this is part of some kind of binary download, or some kind of of software download. It looks like, because you can see all of this. This is basically like the help portion of that. So even when you get a program that you're downloading that's basically binary code, there can be portions of it that are text, stuff like help information, just parts of like a user interface. So sometimes there's useful information in one of those things. And one of the program, actually, if you were to sort of export this, if you were to export this as a blob of text, you could use a program called Strings to analyze it. And Strings will go through a big blob of data and find all of what appears to be readable strings within that large blob of data. The fact that this is that traffic is all on these higher level ports is weird, because normally a download wouldn't be that way, right? And then you have this other long duration session on from that same machine that has a lot more packets and a lot more data. So it makes me wonder what that is. I don't know if I ever actually opened that in this session. Here's an example of what an HTTPS session looks like. You can see them exchanging certificates and setting up the encryption, but once you get past that, the session's encrypted and you really can't read it anymore. And there's nothing more to see in that session. So that's really all I had to show you here in Wireshark at this point. Hopefully that gives you some techniques to use to kind of get started on doing analysis in Wireshark. We did find those malicious sessions early on. There wasn't really much interesting over them, so that's kind of it. I'm going to go ahead and upload this, and then we'll take a look at using Encase.